The first question is, which variable is the dependent variable? In our situation, the amount that she makes is dependent on the number of hours she walks. So her earnings depends on the number of hours. Therefore, dependent variable is earnings. Which variable is the independent variable? Well, the independent variable is the number of hours. The number of hours she walks the dog determines how much money she earns. Therefore, number of hours is the independent variable. To construct a table of values for up to 5 hours worked, we have to have in our independent column our number of hours H and our amount of money earned in dollars in our dependent. Well, for 0 hours worked, she makes $0. For 1 hour worked, she makes $12. For 2 hours worked, she makes $24. For 3 hours worked, she makes $36. For 4 hours worked, she makes $48. And for 5 hours worked, she makes $60. The first differences in this are all a constant value of 12. This means that the rate of change of her pay is $12 per hour, which matches up with the question. When we graph this relation, we use our table of values to construct points. And this is what our graph looks like, with the total cost of dog walking along the dependent axis and the number of hours worked along the independent axis. If we examine our graph and try and look for the slope, we have to go through 2 points. We have a rise and a run. Recall our slope formula is rise over run. Well, the rise in this situation comes from 48 minus 12 for a rise of 36. And the run comes from 4 minus 1 for a run of 3. So our rise over our run is 36 divided by 3, which simplifies to 12. Note that the slopes between any 2 points on this graph are 12. Doesn't matter which 2 points you choose, you will calculate the same slope along a straight line. But also note that the line crosses the y-axis at the point 0, 0, meaning that the y-intercept b is b equals 0. That's because if Anna doesn't work, she doesn't earn any money, which is similar to most part-time jobs. Compare also the slope of 12 and her hourly rate. Also add to comparison the first differences. Notice how all of these are the same number. Since the hourly rate is called the rate of change, the slope and the first differences will represent this rate of change. Write the equation E, which represents Anna's earnings, and H represents the number of hours worked. Well, similar to the last question, we know that the y-intercept of the line is 0. And the slope of the line, or the rate of change, or the first differences, is 12. The dependent variable y is Anna's earnings. We'll let E represent Anna's earnings. The independent variable x is the number of hours worked. We'll let H represent the number of hours worked. Our line is going to be defined in the format y equals mx plus b. Remember, this is slope y-intercept form. Except instead of dealing with the regular dependent variable y, we're going to substitute e. Our slope we've calculated as the slope of the line, or the rate of change of the first differences, of 12. Instead of dealing with our independent variable x, we're going to substitute our variable that we've chosen, h. And our y-intercept is 0. So we don't have to write plus 0. We're actually finished with our equation here.